Hello everyone, today I will do room introduction to SIEM on TryHackMe, and I hope so that you will follow me. So first test, what is the SIEM? SIEM stands for Security Information and Event Management System. It's a tool that collects data from various endpoints, network devices across the network, stores them at centralized place and perform correlation on them. This room will cover the basic concepts required to understand SIEM and how it works. Learning objective. Some of the learning objectives covered in this room are: what is SIEM and how does it work, why is SIEM needed, what is network visibility, what are log sources, and how is log ingestion done. What are the capabilities a SIEM provides? So what does SIEM stand for? That's Security Information and Event Management System. After that, moving on task 2, network visibility through SIEM. Before explaining the importance of SIEM, let's first understand why it's critical to have better visibility of all activities within a network. The image below shows an example of a simple network that comprises multiple Linux Windows based endpoints, one data server and one website. Each component communicates with the other or accesses the internet through a router. So we have here router, internet, data center, web center, 20 Linux workstations, 50 Windows workstations. And if we want one by one to log the sources, it's so much difficult job, and it will take some time. So because of that, we are using SIEM, and that's making our job so easy. As you know, each network component can have one or more log sources generating different logs. One example could be setting up sysmon along with Windows event logs to have better visibility of Windows endpoint. We can divide our network log sources into two logical parts. Hosting-centered log sources. They are log sources that capture events that occurred within or related to the host. Some log sources that generate host-centered logs are Windows event logs, sysmon, OS query, etc. Some examples of host-centric logs are a user accessing a file, a user attempting to authenticate, a process execution activity, a process adding, editing, deleting, a registry key or value, PowerShell execution. This is all host-centric log sources. And we have network-centric log sources. So network-related logs are generated when the hosts communicate with each other or access the internet to visit a website. Some network-based protocols are SSH, VPN, HTTP, HTTPS, FTP, etc. Examples of such events are SSH connection, a file being accessed via FTP, web traffic, a user accessing company's resources through VPN, and network file sharing activity. So now, importance of SIEM. Now that we have covered various types of logs, it's time to understand the importance of SIEM. As all these devices generate hundreds of events per second, examining the img logs on each device one by one in case of any incident can be a tedious task. This is one of the advantages of having a SIEM solution in place. It not only takes logs from various sources in real time, but also provides the ability to correlate between events, search through the logs, investigate incidents, and respond promptly. Some key features provided by SIEM are real-time log ingestion, alerting against abnormal activities, 24/7 monitoring and visibility, protecting against the latest threats through early detection, data insights and visualizations, ability to investigate past incidents. Answer the questions below. Is registry-related activity host-centric or network-centric? The answer is the host-centric. Because we have here a process adding, editing, deleting, and registry key. So, is VPN related activity host-centric or network-centric? And we see here a user accessing company resources through VPN, and this is the network-centric. Okay, moving on task 3, log sources and log ingestions. Now we see every device on the network generates some kind of log whenever an activity is performed on it. like a user visiting a website connected to SSH, logging into his workstation, etc. Some common devices that are found in network environment are discussed below. Windows machine. Windows records every event that can be viewed through the Event Viewer utility. It assigns a unique ID to each type of log activity, making it easy for the analyst to examine it and keep track of. To view events in Windows environment, type Event Viewer in the search bar and it takes you to where different logs are stored and can be viewed as shown below. These logs from all Windows endpoints are forwarded to SIEM solutions for monitoring and better visibility. And here is the Event Viewer. I made a video about it, then you can understand how it works, and it has on YouTube so much videos from Event Viewer, and you can go and watch it. Linux Workstation. Linux operating system stores all the related logs such as events, errors, warnings, etc., which are then ingested into SIEM for continuous monitoring. Some of the common locations where Linux store logs are var log httpd contains HTTP request, response and error logs. Var log cron, events related to cron jobs are stored in this location. Var log authentication log and var log secure stores authentication related logs. Var log kern, this file stores kernel related events. Here is a sample of cron logs. After that, moving to the web server, it's important to keep an eye on all the request responses coming in and out of the web server for any potential web attack attempt. In Linux, common locations to write all Apache related logs are var log Apache or var log httpd. Here is an example of Apache logs. So after that, log ingestions. All these logs provide a wealth of information and can help in identifying security issues. Each SIEM solution has its own way of ingesting the logs. Some common methods used by these SIEM solutions are explained below. Agent forwarder. These SIEM solutions provide a lightweight tool called an agent forwarded by Splunk that gets installed in the endpoint. It's configured to capture all the important logs and send them to the SIEM server. Syslog. Syslog is widely used protocol to collect data from various systems like web servers, databases, etc. are sent real-time data to the centralized destination. Manual upload. Some SIEM solutions like Splunk, Elk, etc. allow users to ingest offline data for quick analysis. Once the data is ingested, it's normalized and made available for analysis. Post-forwarding. SIEM solutions can also be configured to listen on a certain port and then the endpoints forwarded to the data to the SIEM instance on the listening port. An example of how Splunk provides various methods for log ingestion is shown below here. After that, in which location within a Linux environment are HTTP logs are stored. So HTTP stored is on var log httpd. After that, moving on task 4, why SIEM. SIEM is used to provide correlation on the collected data to detect threats. Once a threat is detected or a certain threshold is crossed, an alert is raised. This alert the analysts to take suitable actions based on the investigation. SIEM plays an important role in the cybersecurity domain and helps detect and protect it against the latest threats in a timely manner. It provides good visibility of what's happening within the network infrastructure. SIEM capabilities. SIEM is a major component of Security Operations Center (SOC) ecosystem is illustrated below. SIEM starts by collecting logs and examining if any event flow has matched the conditions set in the rule or crossed a certain threshold. Some of the common capabilities of SIEM are correlation between events from different log sources, provide visibility on both host-centric and network-centric activities, allow analysts to investigate the latest threats and timely responses, hunt for threats that are not detected by the rules in place. And we see here SIEM, security information and event management, reporting, ticketing, log collection, knowledge base, research and development, aggregation, correlation, threat intelligence, and then again. SOC analyst responsibilities. SOC analysts utilize SIEM solutions in order to have better visibility of what is happening within the network. Some of their responsibilities include monitoring and investigating, identifying false positivities, tuning rules which are causing the noise or false positivities, reporting and compliance, identifying blind spots in the network visibility and covering them. Now moving on to task 5, analyzing logs and alerts. SIEM tool gets all the security related logs ingested through agents, power forwarding, etc. Once the logs are ingested, SIEM looks for the unwanted behavior or suspicious pattern with the logs with the help of the conditions set in the rules by the analysts. If the condition is met, a rule gets triggered and the incident is investigated. Dashboards are the most important components of any SIEM. SIEM presents data for analysis after being normalized and ingested. The summary of this analysis is presented in the form of actionable insights with the help of the multiple dashboards. Each SIEM solution comes with some default dashboards and provides an option for custom dashboard creation. Some of the information that can be found in a dashboard are alert highlights, system notification, health alert, list of failed login attempts, event ingested count, rules triggered, top domains visited. An example of the default dashboard in QRadar SIEM is shown below. Here is an example, and we can see here how it's all good, and it's nice to see this dashboard. And moving on, correlation rules. Correlation rules play an important role in the timely detection of threats, allowing analysts to take action on time. Correlation rules are pretty much logical expressions set to be triggered. A few examples of correlation rules are: if a user gets 5 failed login attempts in 10 seconds, raise an alert for multiple failed login attempts. That means maybe someone wants to brute force my device. If login is successful after multiple failed login attempts, raise an alert for successful login after multiple login attempts. If brute force is successful, then someone get the access and you will get the alert. A rule is set to alert every time a user plugs in USB, useful if USB is restricted as per the company policy. This is very good rule. If outbound traffic is less than, but it should be the more than 25 megabit, raise an alert to potential data expiration attempt. Usually it depends on the company policy. So we have, if your traffic is sudden of this alert, then you will get the alert. So how a correlation rule is created. To explain how the rule works, consider the following event log use cases. Use case 1, addresses tend to remove the logs during the post-exploitation phase to remove their tracks. A unique event ID 104 is logged every time a user tries to remove or clear event logs. Interesting, to create a rule based on this activity, we can set the condition as follows. Rule: if the log source is win event log and event ID is 104, trigger an alert event log cleared. So we will know if someone cleared the cleared the win event log, and we will get this alert. Use case 2, adversaries are comments like who I am after the exploitation privilege escalation phase. The following fields will be helpful to include in the rule. Like this comment who I am, when you get the access of you or some machines, like if you get if you are in, you get the access for the machine. First thing what you will do is you will type who I am. You want to see are you the user, are you the root, or what privileges you have on this system. Log source, identify the log source capturing the event logs. Event ID, which event ID is associated with the process execution activity. In this case, event ID 4688 will be helpful, and new process name, which process name will be helpful to include in the rule. So this is basically all of that. Better to understand why you're using this who I am is so if you try to do some machine and to get the access to that machine, then you will see why people all time using who I am. And this is very good rule. After that rule, if log source is event log and event log is 4688 and new process name contains who I am, then trigger an alert. Who I am command execution detected. In the previous task, the importance of field value pairs was discussed. Correlation rules keep an eye on the values of certain fields to get triggered. That is the reason why it is important to have the normalized logs ingested. Alert investigation. When monitoring SIEM, analysts spend more of their time on dashboards as it displays various key details about the network in very summarized way. Once an alert is triggered, the events flows associated with the alert are examined. And the rule is checked to see which conditions are met. Based on the investigation, the analyst determines it's true or false positive. Some of the actions that are performed after the analysis are: alert is false alarm. It may require turning the rule to avoid similar false positivities from occurring again. Alert is true positive. Perform further investigation. Contact the asset's owner to inquire about the activity. Suspicious activity is confirmed. Isolate the infected host. Block the suspicious IP. Let's move on to the next task and explore how SIEM works. So basically this is how they created the rules and how they defend against the attackers. Which event ID is generated when event logs are removed is 104. Which type of alert may require tuning? This is the false alarm. Alert is false alarm if it may require tuning the rule to avoid similar false positivity from occurring again. Now we are going to lab work. Lab work. Click on the view site button, which will display the lab on the right side of the screen. In the static lab attached, a simple dashboards are events are displayed. When a suspicious activity happens, an alert is triggered, which means some events match the condition of same rule already configured. Complete the lab and answer the following questions. Click on Start Suspicious Activity. Which process caused the alert? They're saying as this process is well-known mining software. https www.kudaminer.com. Oh, view site, start activity, start suspicious activity. Now here we get here the process names and we get the kudaminer.x. Potential kudaminer activity observed. Find and click on the triggered event to show the details. Find event. Find the event that caused the alert. Which user was responsible for the process execution? We are moving on the right. Scroll. And we see here that we have kudaminer.x. And what is the user? User is Chris Ford. Okay, what is the host name of the suspected user? The host name is hr02. Examine the rule and suspicions process. Which term matched the rule that caused the alert? So I'll just click to this proceed, and they saying us which rule. There is the rule alert potential kudaminer activity if event ID is equal 4688 and the log source is equal Windows 7 logs and process name is equal miner or crypt. So you will say it's miner, and this is true. Now go to the analysis actions. What is the best option that represents the event? Choose the following: false positivity or true positivity. This should be true positivity. And after this, if the true positivity is, then isolate the host. True. true positive, and after that we get the flag, and this is the all of this room. This room was the easy, but this is just introduction to SIEM, and now you have the understanding what is SIEM and how it works. And later of the other rooms you will do some practical work. Here, so here is a conclusion. In this room we have covered what SIEM is, its capabilities, and what visibility it provides. To learn in depth about how incidents are investigated, explore the following rooms and challenges: Junior SOC Analyst, Splunk, another Splunk, Banning, Investigation with Splunk, Investigating with LKE, and it's busy. Okay, that is all. So guys, I hope so that you enjoyed the video, and thank you for watching. Bye.